Lesson 11.3 on indirect measurement. Let's do a little review before we get to today's lesson. Say we were given these two triangles and we were told that these triangles were similar. Triangle ABC similar to triangle DEF. We're asked to find the length of x there. Now since these triangles are similar, we know that the sides are proportional. So if we set up a proportion between side length AC and side length DF, that ratio there, 24:40, and make it equal to a ratio between length AB and length DE, 9 over x, and we set up this proportion, we can cross multiply to find out what x equals. Cross multiplying, we get 24x equals 9 times 40. If we do the math, it works out where x equals 15. Now in today's lesson, we're going to be doing a process called indirect measurement. Say, for example, a 6-foot man casts an 18-inch shadow at 2 p.m. At the same time, a tree casts a 4-foot shadow. Calculate the height of the tree. At first, you might be asking yourself, what does shadows and people have anything to do with similar triangles? But we can make use of similar triangles to solve this problem. To help us out, let's say that we had a couple diagrams here, one being a person who stands 6 feet tall, and another diagram of a tree. We don't know the height of the tree. But this 6-foot tall person casts a 4-foot shadow. Now remember, shadows are cast by the sun and the sun's rays. And so if we actually think about the picture of the sun there, casting a ray down on the person, creating a shadow, that shadow is 1.5 feet long. Likewise, this tree, a ray from the sun casts a shadow down from the tree and casts it down onto the ground, and we know the shadow is 4 feet. If you look closely, you may recognize now where triangles come into play. The sun's rays casting shadows upon the ground here is the hypotenuse in each of these two triangles. Here in this first triangle and this second triangle, the hypotenuse is formed by the rays of the sun, and the height of the person, the height of the tree, the length of the shadows, all form the legs and the sides necessary to create right triangles that we can use for similarity. Using these triangles, we no longer have to worry about the heights of the people or the heights of the trees. Let's just study the triangles themselves. Here we have two triangles where now we know the proportional lengths of the height of the tree and the height of the person, 6 over x, to the length of the shadow and the length of the shadow of the person, the length of the shadow of the tree. If we set up that proportion, 6 over x equals 1.5 over 4, we can then cross multiply and solve this problem. So x equals 16 feet. Using similar triangles is a way of indirectly measuring the heights of unknown objects or the lengths of unknown objects. And we can make use of that using similar triangles. Thus concludes today's lesson.